Hello to everyone. I'm going to present the work Automated Data-Driven Approach for Gap Filling in Time Series using Evolutionary Learning. And I would like to start with actuality of research problem. And so gaps in data may appear due to various reasons. And we need to deal with it somehow. Because presence of gaps can complicate both retrospective analysis and obstruct operational tasks, we cannot perform some statistical analysis based on our data with gaps. So the main aim of this research work is to development of an efficient algorithm for filling gaps in time series. So there are quite a lot of methods which allow us to restore values in time series which has gaps. And we can start with such simple methods as linear interpolation and moving average, and going to Kalman filters and spline interpolation as more advanced. But unfortunately, in some cases, in even advanced methods, and also we can also use Fourier transform, etc., and different frequency analysis methods. It depends on the task. So, but nevertheless, in some cases, we can get in very inaccurate results. For example, you can check it. You can see such results on the slide. On the right part of the slide, we can see the example of applying linear interpolation and spline interpolation, and see that it's not good enough. And we also can use iterative time series forecasting for filling in the gaps. So we just used the prehistory part before the gap to train our model, forecasting model, and give a forecast into the gap part. And the forecast horizon for this model will be equal to the gap length. So we can repeat it until the end of the time series and just filling in the gaps in such way. To do our forecast, we can use various models and methods. We can start with autoregressive model, moving average model, their combination in ARMA, RIMA, etc. We can use also frequency analysis of time series to make up predictions. We can use additive models, multiplicative models, or even regression approach with machine learning models, neural networks, and much more. But in some cases, we need to perform preprocessing to our time series to make our forecasts more accurate. So preprocessing plus models here is just pipeline, the single structure, and we were talking about such pipelines during this presentation. So I'm going to use pipeline, chain, and composite models as synonyms during this presentation. And the main idea of data flow in pipeline is that we can give our input data to the primary nodes, then we make a prediction forecast, and this forecast becomes predictors for next level model until the end of pipeline in root node. About preprocessing, the first transformation we are going to apply on our time series is large transformations, because we're going to use machine learning models to give predictions, and such models require tables to be trained on it. And so we just use lags as predictors and target to be predicted. Such transformation has one hyperparameter, and this hyperparameter is window size. To sum up, you can see this demonstration in animation, how we can use a large transformation to prepare a large table. Then we use this table to train the model and give forecast for three elements above ahead, and get quite good. On this slide, you can see different examples of pipelines we can build using large transformation. The first pipeline is just simple one, large transformation and every machine learning we want. Second pipeline is combination of large branch with machine learning to make predictions and classical time series forecasting models such as ARIMA. And pipeline number 3 is large separations, maybe with different window sizes. It's also possible in one pipeline. That's good. And the main reason to use evolutionary learning here is that pipelines can be constructed automatically. We can use pipelines as individuals in our algorithm and optimize their operations in the nodes, hyperparameters in the nodes, deleting or adding nodes into the pipeline. We also apply crossover for it, just to swap different subtrees and trying to find the best solution. So the next step is hyperparameters tuning. There are different ways how we can do it when we've got a structure of pipeline. And the most efficient way was simultaneous tuning, because then we change hyperparameters in all nodes, all hyperparameters at the same time. So bidirectional forecast gap filling here on the slide, we can build automatically models to predict values from the left to the right, and then invert right part of the time series and predict values from right to the left, and then combine forecast. We can combine forecast using weighted averaged, as we've done in this work, and also can use another model to combine it. And about case study, in our research, we've used 6 time series to validate gap filling algorithms. The first one is synthetic. Example how we generate synthetic data, you can see on the left part of the slide in the picture. Then we use sea level with data with different discreteness, temperature and traffic volume data. Then you can see how we generate gaps on the right part of this slide. And then we're trying to apply our algorithms and restore gaps in this time series. We compare our algorithm with competitors, and you can see with the metrics that our algorithms outperform all the competitors. And also can check their picture on the right part of the slide and see that the pattern which was restored by our algorithm is not so far from their actual values of time series. We also perform another validation. We use original time series and restored ones for forecasting, and the experiment shows that when we use time series which was restored by bidirectional forecast, the error of the forecasting model was the lowest. So to go to conclusions, here you can see that from this table that our algorithm outperforms all competitors for all time series, but actually it works quite slow if we will compare it with, for example, linear interpolation, because it requires quite a lot of resources, computational resources. But at the same time, it was the most accurate. So all the implemented examples are based on open source AutoML framework which we are developing in our laboratory. And on this slide, you can see their information, contact information about us. So feel free to write to me or check these links, and I will be glad to hearing from you. Thank you for your attention.